Hello everyone, welcome back to another lecture of process modeling and simulation. The module which we are covering these days is related to the reactors. Now coming to the summary sheet, in this batch reactor we have to definitely specify the stoichiometry. Earlier we have specified stoichiometry in stoichiometric reactor and equilibrium reactor, and this is the third reactor where stoichiometry is required. So far, kinetics, definitely this is the first reactor where we have to give the kinetic data as well. And yes, it is a rigorous model and it required one feed. If you want to give more than one feed, it will go into the optional feed. So basically for this batch reactor, one feed is compulsory, while there can be more than one feed. So there are two objectives of the simulation, that to analyze the concentration of reactants and products as a function of time, means we will see the trend with respect to time and plot the temperature profile, and obviously we will be doing the simulation. So this is related to activity number 1, 2 and 4. 1 means fundamental, 2 means simulation, and obviously we will simulate it first, and then the analysis part where we will see that with the passage of time what is the trend related to the concentration of reactants and products. So we have been given this reaction that ethylene reacts with benzene to form ethyl benzene. These are the two specifications of the material streams, which is ethylene and benzene pure. Temperature of ethylene 298 Kelvin, 15 atm pressure, 50 kmol per hour. For benzene 300 Kelvin, 15 atm pressure, 100 kmol per hour. And as I have told you that one feed will be compulsory, required, while the other feed can become in optional. So in this case, the benzene will be the required, while the ethylene will be the optional, and it is regarded as the continuous feed. That ethylene will be fed continuously while benzene will be fed as a batch. Then in reactor specification, the batch feed time is 1 hour, which is this one. Pressure of this reactor is 10 atm. The maximum calculation time is 2 hours. So this is the information which we will be using while giving the values. Then the rate of reaction. If you look at this reaction, then it is minus Ra is equal to C of E, concentration of ethylene, benzene. This is a value of K. If you remember, K e raised to power minus Ea over RT. So you can see this is the representation of a power law. If you go back to CRE concepts, then you will be able to recognize very easily that this is the power law recognition. And if it would have been other model, the representation would be different. So first thing which we have known in the reactor is that we will be using the power law kinetics, because we have to specify the kinetic model. The fluid package which we'll be using is Chaucer, and you can see K is equal to K naught exponential minus Ea over RT. K naught 1.528 multiplied by 8 kmol per second cubic meter, and activation energy is 7.1129 multiplied by 10 raised to power 7 joule per kilomole. So we will be first adding the component, and another thing which you will learn today, benzene and ethylene, they can be added simply by entering benzene and ethylene over here. But this ethyl benzene, first its name is quite big than these two. ethyl benzene अगर आप इधर लिखने भी लगेंगे तो ethyl benzene ऐड नहीं होगा. तो आपके पास दो ऑप्शन है, या तो आप ethyl benzene का डायरेक्ट यहाँ नाम ऐड कर दें, या फिर इसका फॉर्मूला दे दें. और अगर आप C8H10 डायरेक्ट भी देते हैं तो वो पिक नहीं करेगा. उसकी रीजन ये कि C8H10 के नाम से और भी इसमें कंपोनेंट होंगे, तो आप C8H10-4 देंगे. Then Chaucer, then the connection benzene and ethylene, then you will be specifying the power law reactor, then this reaction set. For benzene, the coefficient obviously -1. For ethylene, it will be -1. For ethyl benzene, it is 1, as can be shown in this, that 1, 1. So definitely for these two, it will be -1. And for this it will be 1. But what is exponent? It basically comes from this rate of reaction equation, that Ce raised to power 1. So concentration of ethyl benzene is 1. So exponent is basically 1. This 1 1 came from this reaction rate. If it would have been 0.5, for example, then we will be entering 0.5 over here. Then we will go to this kinetic and we will specify the kinetic values. Then benzene, ethylene will be specified, and then we have to give the specifications of temperature profile, that at 0 minute, 10 minutes and 20 minutes what is the temperature profile. Pressure in the reactor, and obviously there is no catalyst involved, because if you see, then this unit, it is in cubic meter volume of reactor. If this unit would have been in kg or ton or any other mass unit, then we have to specify catalyst. Coming back, then you see batch feed time 1 hour, maximum calculation time 2 hour, time interval you can vary it 10 seconds, then stop criteria is given, and then this is the final result and the plots. This is the temperature plot and this is the concentration plot. And you can see this blue line represents the benzene, this green line represents the ethylene, and this pink line represents the ethyl benzene. So this is how you simulate the batch reactor. Let's quickly go back to Aspen Plus and simulate it. There are different values which are not given over here. Let me शो यू कि यहाँ पे सारी वैल्यूज आपको नहीं दी गई, यहाँ पे आपको सिर्फ 3 वैल्यू स्पेसिफाई कर दी कि बैच फी टाइम 1 घंटा है, प्रेशर 10 एटीएम है, मैक्सिमम कैलकुलेशन टाइम 2 आवर्स है, लेकिन बाकी वैल्यूज आपको यहाँ सिमुलेशन में बता दी गई हैं। तो इससे आपको घबराने की जरूरत नहीं है कि वो वैल्यूज उधर क्यों नहीं दी गई। अगर पेपर में भी ये आता है तो आपको सारी वैल्यूज दी जाएंगी, तो इससे घबराने की जरूरत नहीं। सो बेंजीन, as you can see, is added over here, ethylene is added over here, and if you see ethyl ben, you can see it cannot be added further. So what you do, you will go here, you will add ethyl benzene and you can name it as EB. Then click on next, chow cedar, and then click run. And once done, results are available. Go to the simulation block. Now in this simulation block, go to reactors, and this is the last one, the batch reactor, rigorous batch or semi-batch reactor with rate controlled reactions based on known kinetics. As I have told you that one of the feed will be continuous. It means we are basically dealing with the semi-batch reactor. If it would have been batch, completely batch, then there will be no continuous feed. As you can see, this is batch charge which is required. This is the continuous feed optional. You have to provide this if it is a semi-batch system. And obviously you know the definitions of semi-batch and batch. And this is the final outlet. This is vent, that if there is some vapors produced or you want to vent something. So let me realign it and name it as given in the slides. So you can see benzene is your batch feed, ethylene continuous, and ethyl benzene will be produced. So first we will specify benzene. So you see benzene is specified 300 Kelvin, 15 atm pressure, 100 k mole per hour, and with mole fraction of benzene as 1. Similarly, ethylene will be specified, and you can see ethylene is specified 298 Kelvin, 15 atm pressure, 50 k mole per hour, and ethylene is 1. Now click on next, and you have to specify reactor operating specification. What is that? Constant temperature profile, heat duty profile, thermal fluid temperature, and heat transfer subroutine. So we have been given the temperature profile. We'll click on this. First convert the unit to minutes. It is in Kelvin, 0, 10, 20. The temperature is 300 Kelvin, 400 Kelvin, and 430 Kelvin. It is obviously in reactor should be in liquid phase because it's a liquid phase reaction. Then the reactor pressure is 10 atm as given in the problem statement. Once it's tick, then go to the next step. Otherwise stay on this step until tick ना हो जाए, कि ये टिक होना बहुत जरूरी है। अगर आप इसको टिक किए बगैर अगले स्टेप पे चले जाएंगे तो ये प्रॉब्लम आती रहेगी. Then go to the kinetics and click on this new, this R1. If you want to use any nomenclature, it's up to you, but I'm using R1. And then, as I have told you, there are different reaction sets available: emulsion, free radical, general, ionic, LHW, power law, step growth, and so on. So we will using power law because the equation given to us is of power law. So click OK. It is also active, but where to specify this reaction set, I will show you later. Then the stop criteria. First you need to click 1, enter it as 1. Location, reactor, vent accumulator, or vent. Obviously it's reactor. What is the variable type? If you go back and see, so the variable is time and it is of 2 hours. Then the operation time. Batch feed time is 1 hour. Then maximum calculation time, again 2 hours with time interval between profile. This is just for the maximum number of points. It's 10. So it means we will be getting information about the 722 points between these 2 hours. कि हम जो 2 घंटे में जो कुछ चल रहा है हर 10 सेकंड बाद उसका एनालिसिस देख रहे होंगे कि हर 10 सेकंड में क्या चेंज आ रहे हैं सिस्टम में. अगर आप इसको 20 पे कर देंगे तो आपका स्टेप बढ़ जाएगा. जब आपका स्टेप बढ़ जाएगा तो आपके नंबर ऑफ पॉइंट्स कम हो जाएंगे. अगर आप इसको 30 पे कर देंगे तो ये कम होते जाएंगे. सो 10 सेकंड्स के करस्पॉन्डिंगली आपका 722 पॉइंट्स इसमें आ गए हैं. सो दिस इज, यू कैन सी that all these 4 are tick. You do not need to give any information about the continuous feed because it's already given over here, and flow is constant at inlet value, so it's okay. Now one thing is still left and it is still red because you have not defined the kinetics. We have to find this kinetics. Scroll it down and you can see these reactions. R1, click on this new and specify reactants. What are the reactants? Benzene and ethylene. What is the product? Ethyl benzene. Coefficient is 1. 1 I have entered 1, but it's obviously -1. But this exponent should be positive. And okay. And then go to the kinetic and specify this value. If you see power law kinetic expression, if T naught is specified, it is K T over T naught. T naught is the reference temperature. As you can see, let's you type reference temperature in Kelvin, Celsius and so on. So you do not have been given this shape. So you have to remember this while solving this, that if T naught is specified, then you will specify T naught over here. If T naught is not specified, you will not give any value. Obviously, the concentration is in molarity. There can be other concentrations like molality, mole fraction, mass fraction, partial pressure, so on, but it depends on the provided units. So what you do, what is the value of K? It is 1.528 E of 8. And first convert this unit to joule per K mole. All the information is now completed. So simply click on run, and once after running the results are available and you see reacting phases in liquid. Please be noted that the phase selected over here is the same as the phase selected over here in this specification. If there is a difference in these two reacting phases, then there will be error generated. कोई ना कोई error generate हो जाएगा अगर आपने यहाँ पे कोई मिस्टेक की होगी. तो जो रिएक्टर में आपने फेज दिया हुआ है वही आपके यहाँ पे काइनेटिक्स में भी फेज होना चाहिए. सो आई होप यू हैव लर्न हाउ टू डिफाइन द काइनेटिक्स इन दिस. सो राइट क्लिक ऑन इट, गो टू द रिजल्ट्स. You can see stop criteria, 1 reaction time, heat load per cycle, and this is the whole calculation and the balance over here. But you have to analyze the concentration profile and temperature profile. So what you do, you will scroll it down and go to this profile under B1. B1 is the batch reactor, and under this profiles click here and you can see this is the time, pressure, temperature set value. You can even convert it to degree centigrade, it's up to you. And you can even convert it to degree centigrade and convert it to second. And you can see these are 722 points from 0 second to 7200 seconds. It means 0 hour to 2 hours. So for temperature profile, simply click on this temperature and the profile will be generated for the temperature for reactor. And you can see this is the same profile as we have seen in the slides. That initially the temperature was at 300, then increase. At this point it was 400, then a sharp as to 430, and then the straight one. And this is the same profile which you have identified basically. If you remember that you have defined the temperature profile over here at 0 minute, it's 300. At 10 minutes, it's 400. At 20 minutes, it's 430. So you can see that at 20 minutes, it will be basically this here, where you have specified 430. Here you specified 400. So this is the first part that you have plotted the temperature profile. Now you have to analyze the concentration profile. So what you do, again go to this profile. This tab should be opened, and then in this composition, click here and reactor molar composition. Which components? Select all. And why it is taking time? Because you have specified 722 points. क्योंकि आपके points बहुत ज्यादा हैं. अगर आप यही points कम करोगे तो जल्दी ग्राफ बन जाएगा. And you can see that ethyl benzene is increasing, benzene is decreasing, and you can see this is nearly constant, but it is not a constant value. Basically, this ethylene is also decreasing, but since its value is very small with respect to this composition, so that is why it seems nearly constant, but it is actually not a constant value, it is decreasing. So that's how you simulate batch reactor in Aspen Plus using the values, obviously the stop criteria, the operation times, and the kinetic data. So far we have covered the power law kinetics, but when you go to more regular system, then you also have to deal with LHSW and so on kinetics. But definitely that is not included in your curriculum. So that's it from this lecture. Thank you so much. In our next lecture, we will be simulating CSTR reactor based on these reaction kinetics and the same feed conditions. Thank you so much.